Now that we have a good idea of some of the most commonly used mechanics for locomotion inside of a VR experience, let's create one for our players to use while playing our game. Let's jump straight in. Open the project settings and navigate to the input category. Expand the axis mappings settings. The virtual reality template has provided us with axis mappings for all the common motion controllers. Expand the axis mapping named motion controller thumb left _y. The name of this axis mapping alone should give you a pretty good idea of what input it is listening for. This is for the left thumbstick in the Y axis. Traditionally, this is used to move our player forward or backwards. Motion controller thumb right X is traditionally used to turn the player left or right. These should all be very familiar, but instead of move forward or turn, they are named by their input name and axis. You can of course rename them if you'd like, but I'll keep them as is. Before we add any logic to our motion controller pawn darts, we need to add a couple of variables to our Struck VR player settings. Navigate to the Struck folder inside of the Dev folder and open Struck VR player settings. Add a new float variable named walking speed. Let's set the default to 2.0 and move the variable up in the structure to below the locomotion method. The order is not important, but I like to keep relevant things near each other. Add another float variable named rotation speed and set it to 0.5. I'll also move this one up. Open our motion controller pawn darts so we can add these input functions. Right-click and search for motion controller thumb left X. This is used to strafe left and right. We'll build the rest of this function in a bit. Right-click and search for motion controller thumb left Y, which again is going to be used to move forward and back. Lastly, search for motion controller thumb right X. As mentioned, we will use this to turn the camera. We're not going to be using motion controller thumb right Y because we don't need input to look up or down. We could just do that. A quick note about these three events. Because of their nature, they will each be called every frame to check the axis value of their respective inputs. We need to make a quick solution to prevent it from doing anything unless the player is telling it to do something. To do this in a replicatable way, let's create a new macro named locomotion method. Give it two inputs. The first, an exec named then, and a float named axis. An exec input is simply an execution, simply a way to pass an execution through or into the macro. By naming it then, it hides the name, so I can use this as a standard input. Then a float named axis. Now we're going to add three outputs, all execs. Start at the top, naming it teleport, then controller dash doing nothing. This will all make sense in a bit. Bring in a reference to our Struck VR player settings and break the structure showing only the eLocomotion method variable. From the return, create a switch node and connect it to the input exec. Teleportation plugs into teleport, and then plug standard controller movement into a new branch. Plug true into controller and false into controller doing nothing. From the axis, search for a not equal to and plug the return into the branch condition. Okay, what is happening here is the choice of route that will come out of this macro will depend on the value of eLocomotion method. If the method is standard controller movement, it will choose this route based on if the player has the thumbstick in a position other than 0. We can use this macro not only to prevent the axis values from firing every frame, but also to prevent one method of locomotion if the other has been selected by the player. Let's first add this after the pressed events for teleportation. Because teleportation is not an axis event, the axis value can stay 0 as it isn't used here. Make sure to only add it on pressed and not on released, just in case the locomotion somehow changes mid-teleport. Add the macro to the 3 axis events, making sure to plug in the exec input and the axis. Starting with motion controller thumb left X. From the controller output of the macro, create an add actor world offset node and set sweep to true. For the delta location, we're going to be taking the direction we want to go, restricting it to a plane, and multiplying it by a speed. So get a reference to our camera and get the right vector. Drag from there and search for project vector onto plane. Set the plane normal to 0, 0, 1 so that the plane is flat on the ground looking straight up and thereby limiting our movement to a ground plane. Multiply the result by the axis value from the event. Get a reference to our struct VR player settings and break the structure, showing only our walking speed. Multiply this value to the vector result we previously made, and plug in the result to delta location. This was for moving left and right. Repeat the exact same code for moving forward and back, but change the get right vector to get forward vector. So I'm just gonna select them all, press Ctrl W to duplicate. Controller goes into here. Instead of get right vector, we're gonna get forward vector. This will allow us now to move forward or backwards. Now onto motion controller thumb right X. From the controller output, create an add actor world rotation node. Split the rotation as we only want to rotate in the Z. From the axis value, create a map range clamped node and plug the return value into the delta rotation Z. Set the in range A to -1 and the in range B to 1. These are all the values that we can expect from this input, -1 being all the way to the left and 1 being all the way to the right. Using another reference to our struct VR player settings, show only the rotation speed and plug it directly into our out range B. For out range A, multiply the value by -1. Remember that we set the default of rotation speed to only 0.5. This will keep our rotation slow and hopefully make sure no one gets sick from rotating the camera without rotating their physical head. Inside of BPP pawn darts, set the default value of E locomotion method to standard controller movement and press play in VR. I'm going to try and teleport now that I've changed it to standard controller movement. And the macro should prevent this. So I'm gonna press A, and now nothing's happening, and also with X. But if I use the joysticks, now I can move around on the direction. I know that my plane is working because if I look up in my forward vector, I'm not moving up. I'm bound to this plane. And I can also turn the camera using the right thumbstick. So now I'm moving the pawn around as I would in a normal video game. This is looking good. Let's now create the mechanic to vignette the camera while rotating to help minimize what the player sees at the edges to more assist with the prevention of motion sickness. After the Add Actor Worlds rotation node, create a branch. Get a reference to struct VR player settings and show only vignette screen on rotation. Plug the results into the branch. Make a duplicate of this branch and condition and connect to our macro from the controller doing nothing exec. When we are using standard controller movement and begin to rotate the camera, we want to gradually add the vignette to the screen, and when we stop rotating, we want to take it away more quickly. Select the camera component, and at the top of the details panel, search for vignette. During my experiments, I found 2.5 to be a good value, but feel free to experiment on your own. Be sure to set the post-process blend weight to 0 so the effect is not showing until we need it to. From the true branch, during rotation, create another branch. Get a reference to the camera and search for post-process blend weight. If the value of the weight is less than or equal to 1, add 0.05 to it and set it by a reference. Then I want to add 0.05 to it and we're going to set this, set by a reference, if it is true, to itself plus 0.05. When removing it, we'll do the same thing, but check if post-process blend weight is less than or equal to 0, and if not, subtract by 0.1 and set it by a reference. And I'll compile this. With this, if we hold onto the rotation thumbstick, it will increase the vignette until fully active and then do nothing. When we let go, it will remove the vignette until fully gone and then do nothing. Make sure vignette screen on rotation is set to true in our BPP pawn darts. Compile. Let's test once more. So now I can move again and I can look around, but now if I use the controller to rotate, if I push to the right, you can see my screen is vignetting as I'm rotating. You can see it adds the vignette much slower than it takes it away, exactly half as slow. As mentioned, feel free to play with the various speeds of movement and the vignetting until you get a feel that works best for your project. Next, we'll talk about the Oculus Guardian and how we can use it in our projects.